While calculating mean, what we do is we add all the data divided by the total number of data points. Or what we can do is, if data is written in tabular form where xi and fi is there, we multiply xi fi divided by sigma fi. So this is how we take the total value xi fi sum and total frequency sum, that is the total number of data points, and we get x mean. X mean is represented by x bar or x mean. Now we have one more method to calculate the mean. We assume the mean while seeing the data. We assume some number, that this is the assumed mean. That can be a good assumption or bad assumption. The more good assumption it will make your calculation more easy. So you assume something, you assume that this can be the mean, and then you calculate the deviations from your assumed mean. Say suppose you have assumed mean as 400. Let's see, I have written an example for you. So you have a data where xi is 407, fi is 2, xi is 405, fi is 2. So xi you have, fi you have. So by looking at this data, we can see that mean should be around 404, 405. So what we can do is, if you can assume the mean to be 404, it will make your calculation more easy. But you can assume safely, you can assume mean 400. So in this example, we have assumed mean as 400. Now assumed mean is 400. We write it as xa. Now what we do is, we calculate the deviations from assumed mean. So the first data is 7, second data is 405, third data deviation is 2, and the fourth data deviation is 6. So if we have assumed mean as 404, the first deviation would have been 3, second deviation would have been 1, third deviation would have been -1, and fourth deviation would have been 2. So the deviations can be negative also. So now we will calculate sigma difi upon sigma fi. So that is average of deviations. So average of deviations will be 4.8. So the actual mean will be assumed mean plus deviations ka mean. So deviations ka mean 4.8. So we'll get 404.8 as the mean.